I'm going to touch into some of the elements that's been already been talking about today about observability, security, and of course network operation. Um, the this presentation is based on Isovalent Cilium. It's about Kubernetes networking mostly, but it's not only that, because a lot of these things that Cilium is doing and the Isovalent is doing is can also be directly applied to any Linux machine. So first and foremost, I just want to thank all of the presenters until now. It's been very great to see all of your presentations. It's a very interesting day today. And I feel a little bit like an imposter here, because I'm going to talk about stuff that I'm not an expert on compared to everybody else there. So this is why I have this disclaimer. I'm an infrastructure architect. I'm in no way any expert on Linux, BPF, eBPF, Cilium, or Kubernetes. I'm just a guy who loves people, gatherings like this, and I love technology. So I read a lot. I stick my fingers into some things, and I end up knowing some things. So one of the things that I just want to have like a small segue into like the whole end-to-end policy. So it's a little bit about the digital architecture, because everything is now a little bit everywhere. You have something on-prem, something under your desk, in your garage, or in the cloud. So what defines the digital architecture is basically more or less the same as architecture itself. A building has some infrastructure like plumbing and so on, and the same is what exists is the components that do the architecture and the relationship with them, like between them, like the interfaces, integrations, and so on. And in the end, the reason why you chose to build it like that, why you don't have the plumbing running in the ceiling but under the floors, for example. And the reason why I go into this a little bit is because since everything is everywhere, it's not exactly the same as building a building. Because a building, you have like 4 walls and you have a ceiling and everything, but when you have a digital architecture, you have a lot of stuff floating around between on-prem, cloud, someone's home office, and so on. And I'm sure a lot of you guys, like everybody here, has full control of their architecture. I'm 100% sure. There's full governance, full control. So I'm not talking about you guys. I'm talking about our customers and everybody we talk to. Because in general, like I know that everybody has pumped over this router standing there with some cables going through the ceiling and everything, and you wonder, who owns this? What is this for? Can we dare to turn it off or move it or anything? I don't know. Maybe it has to just stay here forever, like until the building is torn down. So this is part of the challenge with having distributed infrastructure, is to have the governance of it, and to have like you have different parts of the infrastructure. Like we have these cloud people, we have this on-prem people, but like what's floating on the top is a little bit the same between, and there's not necessarily a clear ownership of it. And if you have undocumented and ownerless services, that's not merely a risk. It's not merely a weakness, but it's actually a huge risk. And that's where you're going to be attacked. Most of the time, you're going to be attacked anyways. But if you are being attacked and you have governance and you have full control of the service, you will probably be able to resolve it quite quickly. But if someone is attacking a service that you're not even aware of, that's not as simple. So this is just an example framework, and there is like millions of frameworks. I thought this is a good framework for maybe this audience, I don't know, but it's about the governance part. This is by the TM Forum, which is more towards service providers and telecom industry. So if you're not looking into any framework to like have a full governance over your digital architecture, maybe you look into this. So now I'm coming into like the beginning of the end-to-end policy, and it's not like it's haven't been solved before, but Cilium, they try to solve it a little bit more like easier than before. And this is it all started with when you need to add some services into the Linux kernel. You have to go through a process that might take many years, because you have to ask the Linux maintainers to kernel maintainers to agree that they are going to do this, and then they have to implement it, and in the end, maybe it will come to a distribution close to you in 5-6 years. So that's why they thought eBPF could be the solution, because then you can actually program the services you need right into the kernel. And you don't need to wait for Linux distribution like 5-6 years from now to be able to do what you want to do. And I just also have to say, I made this presentation yesterday, so I'm not entirely sure what's coming, but I have a vague idea. So I just wanted to bring out this, because this is a book, O'Reilly book, written by Liz Rice, which is open source officer in Isovalent. And there's a link there, so whenever you get a hold of the presentation, you can download that book. And like the birth of eBPF is stated to be around this time, 11 years ago. So what is eBPF? And I'm sure most of you guys knows what eBPF is. So and I'm sure you are also more expert in this than me. So I'm just gonna go fast through this, because in the end, you don't even need to be an expert on eBPF to use Cilium. So eBPF is basically what I said, that you can make applications to work directly into the kernel, so you don't need to add a new service into the kernel. And these are the points that are important, the point that were for making the eBPF: networking, observability, and security, to make that easier for application developers. And it works a little bit like this, very simplified. You have this user space in Linux with an app, container, whatever, that can work down into the kernel with kernel-specified apps, like interacting with the files that's opened, networking processes going. And if you check out the book from Liz, you will also see examples of how you can make programs, and you can also go into Isovalent labs and actually try a little bit of the programming, like a hello world with the eBPF. eBPF itself has a lot of strong members, and it's very much and very well maintained. So it's not like just something that's gonna fall down when someone doesn't have the capacity, like that one person doesn't have a capacity to maintain it anymore. So it has strong contributions with a lot of strong contributors. So since its birth in 2014, since 2015, there is already in 2023 there was 41 repositories with applications for eBPF, and this is from the state of eBPF report. So I haven't checked this myself, what the status is from 2023 to now, but I can only imagine that it has increased even more. Which leads to why I'm talking about this. It's Cilium, which is one of the biggest applications until now that utilizes eBPF. And Cilium, as I said, you don't need to be a eBPF programmer or expert or anything. You just need to understand that that's the basis of the technology that they are running, which gives them the possibility to make the container network interface, and also, if you want, a lot of the functionality directly on the Linux machine. So this is just like a short timeline of the history of Isovalent. And the most important elements here I want to pull out is Google in 2020, Amazon 21, and Microsoft Azure 22. So they chose Cilium as their standard network interface card, or like the option of a standard internet interface card in Kubernetes in the cloud providers, which means that now wherever you build your Kubernetes clusters, if it's on-prem, if it's in OpenShift or in VMware, or if it's in any of the cloud providers, and it's not only those, it's others also, but those are the major ones, there is no reason why you can't build like a complete Cilium fabric between all the different providers, where you actually can live in a proper hybrid world, where you do actually live the resilience, as it's been talked about here. Because are you truly resilient if you are living just in Microsoft Cloud? Maybe if you have different availability zones and so on, but are you truly resilient? So Cisco acquired Isovalent in 2024. And for me, it makes perfect sense, because Cisco can be customer zero. They can use this in their own technology, and they are already doing that. So I will get back to that a little bit later, because this is everything that runs on Linux can actually take advantage of this. Which means, for example, any of the operating systems, network operating systems for Cisco, the Nexus switches, the routers, and so on. So I don't know how many of you are working with Kubernetes. As I said, I'm no expert, but I know enough to know that it hasn't been easy for network people to get into the whole cloud and Kubernetes thing. And you have like the application developers who sit there and do their own things, and they pick just the container network interface card that works for them. And it's kind of like a disconnect between network and security and the cloud people, which Cilium has simplified a bit, because you can do this all, and actually you can do this all in YAML. So everybody, I'm sure that most of you have been working with the YAML files for almost anything you configure. So all the things that you you can relate to in a network sense, you can also relate to them in Cilium, and that way you can actually be part of the design and the delivery of the network all the way into the container. So this is what Cilium did. They took a lot of these separated packages in Kubernetes, and they just said, okay, let's just try to do something about this, and you can have this as a package. And the best part of it, it's open source. So you have two main ones. It's Cilium and Tetragon. Tetragon is more like end host security. It's meant to be to control or have insight in the traffic, but Cilium is more like the network setup. And they are open source, and I know a lot of people who have been asking, okay, so now when Cisco bought them, it's going to be closed source, or probably not, because Cisco already does a lot with the open source. They are part of developing a lot of open source software in addition to contributing a lot of standards. So I really don't think that it will be closed down. So Isovalent, which now is with Cisco Isovalent, it's more like the enterprise part of it, where you can get service agreements and support and all that, all the good stuff. Did I pass one here now? Yes. So this is basically how it looks like in the Cilium package. You have eBPF running on in the foundation, and then Cilium does a lot of the networking part when it comes to networking for Kubernetes, the mesh networking. So if you're going to mesh between the clouds, if it's public cloud, private cloud, whatever. And they also do a load balancer. So does anyone remember the last time Cisco had a load balancer? The Cisco people is not allowed to say here. Yeah, okay, so what is the name of the, yeah? No, it's ACE, yeah. I heard some of you guys say, and yeah, and it's a bit funny because I believe most of you guys know the 6500 platform, which did actually everything. You could have the firewall module in it, you could have the wireless service module in it, and you had the ACE. There was no limit for what the 6500 could do, and it's a little bit the same, but this is just software. But it's a little bit the same. You have like the Cilium is like the 6500, and then you run everything on top of it. And then you have the runtime security with Tetragon. So down to the policies, because this is why you came, to see the code. So this is just an example of a basic layer 3 configuration between front end, back end, just a regular HTTP request between like just pure layer 2, no 3 rule. Then you add the layer 4 rule, where you have added it's actually going to be on port 80 TCP. Quite simple, it's YAML. And then you have the layer 7 rule, which is the beauty of it. You can suddenly say that, okay, we are gonna allow the get for the /public in this domain. So you can restrict down on the same web server between different applications, restrict it down to the specific path. And this is where the whole eBPF part comes into play, because you do that, you just fetch it from in the kernel when the traffic goes through there. And it's aware of DNS, so you could actually do that with DNS names instead of IP addresses if you want, which should make sense today. And not only that, you have encryption, security between nodes if you want, and you can run that as IPsec or you can run that as WireGuard. I believe the WireGuard option is probably easier and default, but if you choose to do that by IPsec, it's also possible. And when it comes to network like overlay, because maybe you want to build an overlay between the nodes, and then you do that. You can do that with VXLAN, for example. Or if you choose to do native direct routing, but in that case, you have to have the complete end-to-end control of your IP addresses. So if you're building a private cloud, shouldn't be a problem. But if you're interacting with public clouds, might be a problem. So it's just to be aware of that. You have the option to do that in the encapsulation in VXLAN if you don't have the full end-to-end control, where it's neat that you have WireGuard and the VXLAN encapsulation done. But that's not all. You also have the possibility to I will get back to the load balancing, but also you can run everything with BGP. So you can peer down to your leaf switches. So when you're running, let's say this leaf spine setup with your AI compute farm, then you can do with all the CNIs, you can just configure them to talk over BGP. And I have to say, IP version 6 is also supported. So what I just said, and that's one of the reasons why Cilium is really good, because they do the decisions in the kernel. So you do a lot of you remove a lot of overhead that you might have had before when you run sidecars and so on. So now you're just doing it straight away, and you do the decisions of where the traffic is going before you need to go to a higher level, which means that you can get a lot more juice out of your AI fabric. And as I said, the ACE, it actually is a load balancer, and you can install it on a Linux box, so you don't have to run Kubernetes to do that. And it's I'm not 100% sure, but it has like, say, 70–80% of the features you could expect from like Citrix or F5 load balancer. So when you have those niche requirements, you probably will go with F5 or something, but for most of the use cases, you could go with this. And that brings us to the network observability. The Hubble, and the Hubble UI, it's nice enough itself, but the main part here is that you can actually connect this to any observability system you have built up yourself, if that's being the Elk stack or if that's Splunk. And if you want to present it in Grafana, it's all up to you. And Isovalent, they have a lab, a Grafana lab, so you can actually just go through it. I believe it takes like maybe 15, maximum 30 minutes. Older labs are like nugget size, so you don't need to plan to spend like one working day to do it. You can just, most of them is like, say 15, 30 minutes, just sit down, try it. And probably for you guys, it will be like 5–10 minutes, because I'm quite slow at these things. So did I press here? Yeah. So these are just some of the Cilium adapters, and the list is long. But what I want to tell you about this, and I put the source here, but of course you can Google this yourself or AI it yourself. There are customer stories. So you can also figure out what they did, what they use it for. So you can understand, like, how can this relate to me? For whatever reason you would look into it, for your own sake or for your customer's sake. And now I'm coming to what I said in the beginning. So already in NX OS 10.6, you have something called, what was the name of the service? NX Secure, which is based on eBPF, which runs Tetragon. So you can actually look at, and this, what this does is it allows for 0-day patching. So if there is a vulnerability going on, you can just directly patch it with eBPF instead of waiting for how many days or weeks it takes for the developers to make a completely new operating system to patch it. And with that, I will also say, Nico Wiebert, he's like the Cilium star. So I'm sure that if you all saw him here today, you would have been like, after his presentation, you would have given him the vibe and everything. He's writing a Cilium book with O'Reilly. He's brilliant. Follow him on LinkedIn or chat him up. I'm sure that he will, if you even want him to come and present something, he's willing to do that. He's really good at these things, and he's a good guy to be connected with. So that leaves me. And the presentation is probably shorter than 30 minutes, but that gives you more time for some break. But it's a call to action. As I said, these labs, and some of these labs are a little bit longer and harder, and some of them are shorter and easier. So you have, like I said, getting started with eBPF. That's a very short, simple lab, and you can make like this hello world eBPF code. Maybe it will take you half an hour, maybe 1 hour, I don't know, but it's very specific and it's guided in a very good way. So I really enjoyed the labs I have done, and they are built on a very good platform, Instruct. So it's like the whole lab environment is very smooth. And these are just a few of the labs. They have, I believe it's like 40 labs or something. I would really recommend you to go and check them out. Any questions? I could probably not answer it, but go ahead.